We're going to look at more regular polygon area, and we're going to look at the ones that involve trigonometry today. So this pentagon that we talked about yesterday, when we talked about our general vocabulary of radius, apothem, side, perimeter, and area, we talked about how to find this top angle. And how to find the top angle, again, is 360 divided by 2 times the number of sides. So when the top angle ends up being a strange number, meaning that it's not one of our special rights, when it's not a 45 and it's not a 60 and it's not a 30, something like a 36 here for this pentagon, we're going to end up using trigonometry. So I'm going to show you a few examples where we will use trigonometry. So it says find the perimeter and area of a regular pentagon with a side of 8 meters. Now you could draw the full pentagon, but what I typically do is I draw just the main triangle at the bottom of the pentagon. And I'm going to try to make that a little bit larger of an image. So I draw the triangle at the bottom. And I'm drawing what would be the full bottom triangle of the pentagon. By that I'm talking about this entire triangle here on the bottom. The next thing I'm going to do is I'm going to divide that in half because our math only uses half of this triangle. So that's my apothem. It's kind of slanted, but we're just going to go with it. So this top angle here, this piece, is the 360 divided by the 2n portion of the problem. So the number of sides, it's a pentagon, so it has 5 sides. So we're going to do 360 divided by 10 because n is 5. That's going to give us 36. So this top angle here is 36. So we are focusing on this triangle on the right side. And the reason that I draw the entire triangle is to help myself remember that the full side is to have to double the part that we're going to get with trigonometry. So they said the side length is 8. So this is 8, and so this is 4. So we're going to need to use the 4 in our math, and 36 is the top angle. And the formula for area is 1/2 apothem times perimeter, or apothem times perimeter divided by 2. So I need to find the apothem. Now they did also ask for perimeter, so we're finding perimeter and we're finding area. We could do the perimeter right now without doing any math. We have a side length of 8, it's a pentagon, there's 5 sides, so 5 times 8, 40 meters is the perimeter. So I have the perimeter ready to go for my math. So I have the perimeter part, I know to divide by 2, I just need to find the apothem. So here's the apothem, and we're going to use trigonometry. So 36 is my angle, the 4 is opposite from it, the apothem is the adjacent side to the angle. So I'm using O and A, and that means I'm going to use tangent. Tangent of 36 is equal to the opposite over the adjacent. So A tan 36 equals 4. So we're going to divide by tangent 36 to get the apothem. Remember to make sure your mode is in degree. 4 divided by tangent 36 is 5.5. Now you can use the full decimal that you have in your calculator to continue your math, but for the assignment that we're doing, which is a Canvas quiz, we've set it up where if you happen to round at this point a little bit, you should have a range of values that it will accept. So 5.5 times 40 divided by 2 is 110. So the area is 110 meters squared. And that's how you would do for a pentagon. Here we have a nonagon. This is a shape that I totally cannot draw. So again, drawing the triangle, just going to be my best bet for solving this. Drop in my apothem. So again, this top angle, 360 divided by 2 times the number of sides. Being a nonagon, it will have 9 sides. So 2 times 9 there. So I'm going to do 360 divided by 18. As you're solving this, remember you have to multiply these together before you divide the 360 by that number. Because if you just hit 360 divided by 2 times 9, it's going to divide by 2 and then multiply by 9. You're going to get a crazy huge angle, and hopefully you'll realize that something went wrong. So 20 is the top angle here. Says inscribed in a circle with radius of 5. Remember that the radius of the polygon is the same as the hypotenuse of this triangle all the time. So the radius is 5. And we want to find the perimeter and the area. So we don't have the side measurement. We're going to need to find that. We're also going to need to find the apothem. I'm going to call this A, and I'm going to call this X just because S is a terrible variable, and this is only half the side anyways. So if I want to solve for the apothem, I'm just going to go ahead and do that part first. So I'm going to label the triangle. This is the hypotenuse. This is the opposite side. And this is the adjacent side for the 20-degree angle. Think of Sokotoa. Some old horse caught another horse, taking oats away. And I want to find adjacent, and I have hypotenuse. So I want to use A and H, and that means I'm going to use cosine for this part. So the cosine of 20 equals to the adjacent over the hypotenuse. And so I'm going to be cross multiplying, and I'm going to get 5 times cosine 20 equals A. That really looks like a 9 there. It's an A. So we're going to multiply 5 times cosine 20. So this is going to give me 4.69846, blah, blah, blah. If you're using a graphing calculator, you could store this value. Right above the button that says on, it says STO with an arrow. And so after you get your answer, if you push that STO, and then you push the green alpha button, and like the button under there where it says A in green above it, you could store this as the letter A. And then when you want to use it, you would just hit alpha A, and it would put that letter into your math, and you would be using that value. It's pretty interesting. Okay, so that's the apothem. Now we need to find the perimeter. To find the perimeter, I'm going to need to find X, and then I'm going to have to double it. So if I'm looking for X, then I am looking for the opposite, and I'm going to use the hypotenuse for that. So O and H, and that means that I'm going to use the sine function. So the sine of 20 equals to the opposite over the hypotenuse, and so I'm going to be doing 5 times sine 20 to get X. So 5 times sine 20. And this gives me 1.710100, blah, blah, blah. Now, to get the perimeter, what I'm going to do is I'm going to multiply this by 2. And then that gives me the whole side. And then I need to take that number and multiply by 9 because there are 9 sides. So this gives me about 3.42, and then I'm going to multiply that by 9. And that gives me 30.78. So my perimeter is about 30.78. And that just said units. And then my apothem is what I'm going to need to find my area. So I'm going to change colors here. So the area we're going to find by doing the apothem, the 4.69846 number, times the perimeter, and divide by 2. That totally doesn't look like a 2. There we go. So 4.69846 times 30.78 divided by 2 is giving me 72.3092994. So I'm going to say 72.3. And that would be units squared. So remember that we have our Canvas quiz set up to accept a range of values because there was quite a few places that I was having to round in this problem. And so if you're having to round in the problem because you don't necessarily have a graphing calculator, don't stress over that. Just go ahead and, round to like 3 decimal places or something as you're going through the problem. That way you have very accurate numbers that you're using. And then, just round at the end and kind of round as you're going with what you're needing to. Like here I did a lot of decimal places, but even if you only did 3 of these decimal places, you would get a very accurate answer. And then it should be accepted because of the way that we set up the answers in the problem. One last one, we have a regular octagon with side measurements of 3. Being an octagon, we know there's 8 sides. And if the sides are each 3, then 8 times 3 is going to give you the perimeter of 24 centimeters. For the area, we want to do the apothem times the perimeter divided by 2, so I'll need to go find the apothem. So, got your triangle, got your apothem. They told us the side is 3, and that's the whole side. And that means that this part is 1.5. To get the angle I'm going to use, I'm going to do 360 divided by 2 times 8. That means that I'm doing 360 divided by 16. 22.5. So this top angle here is 22.5 for this part. So we need the apothem, and that is here. So we're going to be using the opposite side and the adjacent side and the 22.5 degree angle, O and A. O and A means that I'm going to use tangent. So the tangent, 22.5, opposite over adjacent. So A tan 22.5 equals 1.5. And then I'm going to divide by tangent 22.5. So the apothem is 1.5 divided by tangent 22.5. About 3.62. So we're going to do 3.62 times 24 divided by 2. And they didn't tell me where to round, so I'm just going to leave it as this. So 43.44 centimeters squared. For our area there. And that's pretty much all there is to it. So it's just all about this triangle at the bottom of your shape. You don't have to draw the full shape. And the angle at the top, very important that you calculate that part. And then you use trigonometry to find the piece that you're needing to follow through with the problem.